When you think of World War II code breaking, I bet one image pops into your head. The Enigma Machine, right? It's famous, it's in all the movies. But what if I told you that Enigma, as amazing as it was just the tip of the iceberg? Well, today we're going to pull back the curtain, because the story of WW2's ciphers is so much bigger and so much stranger than you think.
Okay, let's set the scene. It's World War II. Information is the most valuable weapon there is. Getting a message from a general to a tank commander securely, without the enemy listening in, that could literally win or lose a battle. For the German army, the tool for that job, day in and day out, was the Enigma Machine. It was their workhorse for scrambling messages on the front lines.
So here's the twist. What if that legendary machine, the one Alan Turing and the codebreakers at Bletchley Park famously cracked, was actually considered kind of routine by the German High Command? What if, for their most secret communications, they were using something else entirely, something that made Enigma look like a child's toy? To really get our heads around the crazy stuff that came later, we've got to understand the original. So, let's do a quick teardown of the Enigma Machine and see what made it tick. And here it is, in all its glory. The German army started using these back in 1925. It looks kind of like a typewriter, right? You've got your keyboard to type the message, this panel of lights up top where the encrypted letter would pop up, and that wild-looking switchboard at the front. But the real secret sauce, well, that was hidden inside.
The absolute heart of this thing is a set of these, rotors. Each one is basically a hockey puck of plastic and metal, internally wired like a chaotic maze. An electrical signal goes in one side at the letter A and comes out the other side as, say, the letter Q. The operator would pick 3 of these rotors from a box and slot them into the machine.
Now, just one of these rotors creates a simple substitution cipher. You know, A becomes Q, B becomes X, and so on. So if you type the word Roosevelt, a single rotor might spit out SMMGZCZDT. But a simple substitution cipher like that, an experienced codebreaker could crack that pretty easily.
But of course, Enigma used 3 rotors. And here's the genius part. Every time you pressed a key, the first rotor would click forward 1 position, changing the substitution. And once that first rotor made a full circle, it would kick the middle one forward, just like the odometer in an old car. So the substitution alphabet was different for every single letter you typed.
And just when you think it can't get any more complicated, the military added this thing, the plug board. Before the electricity even got to the rotors, these cables would swap pairs of letters, so an A might become a P before it even started its journey. Then, after going through all 3 rotors, it came back through the plug board and could be swapped again. It was just a brutal extra layer of complexity.
So what does all this mechanical madness add up to? Well, with the standard 3-rotor setup, you could type 16,900 characters before the entire machine pattern repeated itself. For its time, that was a staggering number. It seemed unbreakable. But it was not the end of the story. Not even close.
And this right here is the key. You have to think about it like this. Enigma was for the grunts, for the battlefield, for tanks and U-boats. But for the really, really sensitive stuff, the messages going between Hitler and his top generals, they were using a whole different class of machine. The Allies gave this whole category of ciphers a nickname, fish.
So let's talk about these fish ciphers. We're not talking about people tapping out Morse code anymore. These things were attached to teletypewriters, machines that sent huge streams of text over the radio between major command posts like Berlin and the front lines. This was for high-volume, top-secret traffic. And these machines didn't even think in terms of letters. They spoke a different language, baudit code. You can think of it as a really early version of binary code. Instead of 1s and 0s, every character was represented by a pattern of 5 electrical pulses, either a mark or a space.
So, as you can see here, the letter A is just mark, mark, space, space, space. D is mark, space, space. Everything, every letter and number had its own unique 5-part signature. This was the fundamental language they were working with.
So how in the world do you encrypt something like this? The method was actually beautiful. You take your plain text message in baud.code and you mix it with a super long, super secret key stream of random baud characters. The rule was simple. If the 2 impulses you're mixing are the same, the result is a space. If they're different, the result is a mark.
And this mechanical monster is what created that secret key stream. This is the Lorentz SG42.
which the British codebreakers nicknamed Tunny. Forget 3 Enigma rotors. This beast had 12 different wheels, all spinning at different rates, all interacting with each other to create a key stream so long and so complex it was practically random.
But here's where it gets really wild. Even as these incredible machines were being deployed, the Germans were already trying to invent the next big thing. And this brings us to a man named Fritz Menzer, a brilliant cryptographer whose job was basically to be a professional paranoiac, to find the weaknesses in Germany's own codes before the enemy did.
Menzer zeroed in on the fundamental flaw in almost every cipher machine of the era, including Enigma. The motion of the wheels was regular. It was complicated for sure, but it was predictable. It followed a pattern, like an odometer. And for a codebreaker, any pattern, no matter how complex, is a thread you can start to pull.
I mean, take a look at this machine, the American M209. It was a very good, very common system, but its key wheels just stepped forward one position every single time a letter was encrypted. That clockwork regularity was exactly the kind of weakness Menzer was obsessed with eliminating.
And here's the result of his first attempt to fix it, the Schlüssel-Gerät 39. Just look at this. We said Enigma's cycle length was about 17,000. That's pretty good. The SG39 had a cycle length of 270 million. It wasn't a small step up, it was a quantum leap in complexity.
But Menzer's true masterpiece was the SG41. This thing completely shattered the idea of predictable motion. It had a special control wheel that decided if the other wheels would even move. Then, if they did move, they might step once, or maybe they'd jump forward 2 spots. And just to cause maximum confusion, sometimes that control wheel would just flip the final encrypted letter into something completely different. It was pure, deliberate, mechanical chaos.
So when you look at all these machines together, you realize this wasn't just a static fight over cracking one device. It was a relentless, high-stakes arms race of the mind, a constant cat-and-mouse game between the people building the codes and the people trying to break them.
This timeline really puts it all into perspective. I mean, think about the speed of this. In 1925, Enigma's regular stepping rotors were the peak of technology. Just 15 years later, you've got the 12-wheeled Tunny using a totally different system. And then just 1 year after that, the SG41 comes along with its intentionally irregular, unpredictable motion. The rate of evolution was just breathtaking.
It really makes you wonder, doesn't it? Today, we've moved from gears and rotors to digital encryption and quantum computers. But has the fundamental battle really changed? Is the concept of a truly unbreakable code just a fantasy? Or is that secret war between the code makers and the code breakers still being fought right now, just with different weapons?